something in JavaScript to be able to actually create, run, and execute machine learning algorithms and machine learning models directly in JavaScript without having to, let's say, learn a separate language. It is also really cool technology for creative professionals who might not have prior knowledge with machine learning or prior knowledge with, let's say, Python as well. So we'll see some of the superpowers related to JavaScript and machine learning in JavaScript today. So there are primarily three different ways in which you can basically run TensorFlowJS. The first one is the existing models. This is targeted towards absolute beginners. So using these existing models, you don't need to know any amount of machine learning at all. So even if you are just heard the terms machine learning for the first time, you will be able to actually use it. Then we have a couple of other ways which we'll be covering later on. The second one, which is retraining the existing models, that's what we are really focusing on with a special emphasis on how you can basically enable that with help of the GCloud platform as well. So first, just very quickly onto the pre-trained models. So basically, Google provides you, or the Google TensorFlowJS team provides you a number of different pre-trained models. So these are as simple as just importing the code, and within just 7 to 10 lines of code, you can basically create some really fun machine learning applications. So if you can basically go to TensorFlow.org/js/models. So this will basically redirect you to all the different pre-trained models, and not waste a lot of time today on covering specifically this. But of course, you can definitely check it out or you can connect with me if you need more information about how to run these models. And here are just some of the examples. So this is one of the most famous machine learning models, which is which is used for image recognition and object detection. So here you can see that it's able to detect dogs with 90% confidence, right? And I'm going to show you a few other examples where we are using some of these pre-trained models. So this is face mesh, which basically covers 468 different landmarks for an entire face. It is already being used in production by companies like L'Oreal to be able to do things such as lipstick or basically some kind of effects. Then we have body segmentation, which is able to detect unique bodies within live video or even a face or even a photograph. Then some of the newer models. How many of you have probably seen this kind of effect on Google Photos? Probably if you are a user of Google Photos, you might have seen it. Actually, a lot of you have seen this. So again, this is a power of machine learning in JavaScript, which is with TensorFlowJS. These are some of the newer models that have come up recently. Again, some of the new effects that you can probably think of with, let's say, if you were a creative technologist and wanted to create some kind of fun application in JavaScript, you can basically see some of those. And the main idea is that we want to basically empower developers to be able to not only use JavaScript, but also basically combine the various other huge pool of different libraries that are available today, which allow you to do different things, right? And that's where we are basically showing you how you can explore that. So I'm going to be showing you some examples. So the first one is this really cool lasers example where this developer basically used WebGL, which is used for 3D animation and all, and he used it with TensorFlowJS to create this really cool light effect. Then over here, this is Jason Mays, who's one of the senior developer advocates for the TensorFlowJS team, and he basically used WebRTC, which is used for real-time communication. So you might have probably used it for video communication or even chat. And then A-Frame is used for augmented reality in JavaScript, and 3JS is for 3D modeling, and TensorFlowJS. So you can see that basically what he did was he created a real-time teleportation of himself. And what it just shows is that you can basically combine machine learning in JavaScript with all the such a large pool of NPM modules or libraries that allow you to actually do things like these within JavaScript. And over here, another example created by Jason Mays was a real-time coding estimation. And one of the previous examples that I showcased was how many of you have probably come across, especially during the pandemic, like exercise-based applications, which allow you to basically do, let's say, count your reps directly from your phone. Probably some of you might have used them or might have come across them. So these kind of applications also grew a lot more popular. Actually, one of the applications that I learned with TensorFlowJS was also featured in one of the TensorFlowJS show and tells, which also was built on something like this. But that was done actually before the pandemic at a hackathon. And some of my friends who were part of my team are also over here. So we'll shout out to them. So this is basically to showcase that you can really combine superpowers with TensorFlowJS and combine them with various other technologies within JavaScript to create such kind of really useful effects. But of course, the usage of TensorFlowJS is not just limited to these activities. It's also being used in production by even larger firms, including LinkedIn, right? So you'll see some of the superpowers that you get with JavaScript, machine learning in JavaScript and TensorFlowJS in terms of performance as well. So now we come on to the most important part of today's session, which is transfer learning. How many of you have heard about this term transfer learning? So a few of you. So in a nutshell, what it does is that you basically take an existing model, a machine learning model, and you retrain it over your own data, right? So let's say if you have your own trained data, usually whenever you take a machine learning model, it is pre-trained with some other data. So if you want to, let's say, adopt it to your specific data and your specific needs, you basically retrain it. And that's what you're basically doing with this transfer learning. Now there are two different ways in TensorFlowJS that you can actually do that. The first one is the teachable machine. Now, teachable machine is a web application provided by Google where you just basically have deep learning neural networks in the background, and you can upload either image data or let's say video data as well, or audio data as well, and you can very simply create machine learning models. And this is a very good demonstration for that. So I'll just quickly go to the teachable machine, and that will set the precursor for our next topic that we'll explore with the GCloud platform. So over here you can see by default we basically get the image project, the audio project, and the post project. So we'll take an example of the image project for now, and we'll just take a standard model. So what it allows you to do is that you can basically either upload your own data or you can use your webcam to, let's say, explore the data. Now this is meant for like let's say if you have some small amount of data, let's say up to 100 or 1,000 images, right? So what we do is that we create a real-time classifier, which will basically have two different classes, and we use the webcam to be able to detect it, right? So let's say that the first one that I'll call is this Logitech. I'll just say that I'll give this, so I'll say Logitech, and then what I'll do is I will go ahead and click on the webcam, and I'll just record some of the data points for this, right? So let me go ahead and do that. So I'm doing this right now, as you can see, and I'll just probably take, let's say, up to 70 images. And for the next one, I'll take out my phone, and let's say I'll call my, I'll just name it the phone for my second class, and I'll start recording my data as well. So I'll just probably put it over here, and I'll start to record, and I'll probably take a similar amount of data. So of course, if you are aware of machine learning, you might know that it's very data centric, right? So it's very data heavy. So that's what I've done. Now I'll simply just click on train model. Now you don't require to know what is happening behind the scenes. It has already started to train. So basically it's taking in the input data which is being used as a training dataset, and literally by the time I've spoken within 20 seconds it has already trained it. So let's test it out. First I'll bring out my phone. So take a look at the lower right corner. Over there you can see the outputs, and there are two different types of outputs that we have. So first I'm going to bring my phone, and as you can see that it is able to say that it's 100% confident that it is a phone. And now let me bring the Logitech mic. As you can see that now it's showing 100%. So within like literally 20 seconds we were able to create a full-fledged machine learning application with the help of this teachable machine. And if you are so actually right now, since the data is very limited, right, to make it more effective in terms of the performance, we'll have to add a lot more data. So yes, so I'm just coming back to that. So let's say, of course, this is like really simple, right? You just uploaded the data and you got your results. Now, if you want to be able to also look at more parameters, including, because this is a deep neural network. So if you go to this advanced section, you also get things such as if you want to increase the number of training cycles, which is basically epochs. So in the world of neural networks, epochs basically means how many times you want to train the model. Then you can increase or decrease the batch size. That basically means how much input of your training data you want inside of your training of your model. And then basically you can also see some of the things under the hood as well. That means that if you want to see your confidence matrix as well, right, you can see all of that information and your, let's say, your training accuracy. You can find all of that here in this other section that you see on the right hand side. So this basically just goes on to showcase that even if you don't have any knowledge of machine learning, you can still create machine learning models on the go, right? So I hope that answers some of the questions. So of course, it's still not giving you like a full-fledged way of like let's say being able to tweak each and every parameter of your neural network, but it still gives you enough quantity to be able to do and tweak some of the things to to be able to use them. So this is primarily focused and primarily meant for those developers who are very new to machine learning. And they still want to be able to, let's say, create a machine learning application on the go, probably, let's say, at a hackathon or as a proof of concept. And now what you can do is, the other great thing is that you can basically just go ahead and export this model as well. So you can export it in either TensorFlowJS or core TensorFlow or even TensorFlowLite. So TensorFlowLite is basically a technology which is used for very less powered devices such as your mobile phones. So it's very popular to be able to do that. And as you can see that over here, if I take a look at the source code, which is for the TensorFlowJS model, initially what we're doing is that we're just taking our webcam input and we are fetching our webcam input and we are just running it inside of this predict function, where we are basically running our machine learning inference over this over the photograph that you can see that we are fetching from our webcam, and we are able to run the predictions and fetch the results. Right? So that is one way of doing it. But now we basically come to how you can achieve this if you were to, let's say, have 1 million or 1 billion images, right? Because this teachable machine is good enough if you have, let's say, around 1,000 or 2,000 images, but this is more for proof of concept, right? So this is where we basically talk more about how you can actually use this in production as well. So for that, we are going to talk about Google Cloud AutoML, right? So Google Cloud provides you a number of different machine learning related applications as well, and one of them is to be able to use Google Cloud AutoML. This essentially allows you to be able to, let's say, run computer vision based models, including things such as object detection, image recognition, and even being able to, let's say, extract text from your images as well. So for this demonstration, I've already prepared some of the sample data on the Google Cloud AutoML. So if you want to, let's say, test this out, you need to have a GCP account, and we need primarily 3 different services that we need to enable. So the first one is Google Cloud Storage, which will be used for storing your image data in case you want to store it on Google Cloud, or if you want to upload your own data, you can also do that. But it will still basically be saved on you. And the second service that you need to enable is the Google Cloud AutoML itself. So I'll quickly navigate the AutoML dashboard on GCloud. So this is how it kind of looks like. So this is the vision platform on Google Cloud AutoML. So you can go to console.google.com/vision. So you'll be greeted in this video. So over here you can see that you basically get some prerequisite options, including AutoML itself. Now the first thing that you want to basically do is you have to first start by creating a dataset, right? So this dataset will serve as your images. So you have again 2 options. Either you can basically go ahead and use the, let's say, the Google Cloud shell to be able to, let's say, download some public data which you can basically fetch from Google Cloud shell and save it directly to your Google Cloud storage, or you can also upload your data. So over here, as you can see that I had already downloaded some amount of data, but if you still want to create a new dataset, you first have to just give it a dataset name, and then you have to basically select which particular type of data you actually want. So do you want a single label data? So over here, basically each and every image that you upload, it will only have one single label. If you want, let's say, a single image to have multiple labels, then you can select multi-label. Or if you want to actually do object detection, you can choose that. So in our example that I'm going to be showing today is going to be the single label classification, where it will be basically classifying the image based on its label. And once you select this, you can go ahead and actually create that dataset, and then you have to basically upload your data. So either if you already have your data existing inside of your Google Cloud bucket, so you can basically just go ahead and select that. Or let's say if you want to upload it from your local machine, you can also do that. So we were, let's say, in my downloads folder, I had a number of different images of cats and dogs. So that's what I'm going to be showing. But I've already done that, and I'll quickly show that. So again, you just have to select the number of images that you want. And again, the idea is that since it's running on GCP, this will be able to handle a lot more amount of data, right? So if your training data had billion images, it will be able to handle with this GCP platform. So I already had a few datasets that I created beforehand. So one of them, which is this cat dog 2. So this is again very similar. I had followed all the steps that I just showed you, and this already has some amount of images of cats and dogs, right? As you can see. And what you see over here is that once you basically upload your data, one thing that you have to keep in mind is that if you're using the single label data, you have to basically provide labels to your data. So in this case, since I was creating a project on cat versus dog, So you can see that I have basically two different filters, that's the two different labels. This is the cat and the dog label. And that's what I've provided my labels to each and every data set. And I also have some other data sets as well, which I had more amount of data. So probably this one might have more number of data sets, this close to around 40 data items. So once you have basically 60 items, right? So once you have basically prepared the data, then you basically start to train your machine learning model. Again, very similar to how you saw with the teachers and machine. With Google Cloud AutoML, you don't need to know anything about machine learning at all. The training again will be taken care by the GCP team, right? So it's again using deep neural networks behind the scenes. Again, you don't need to require to know anything about that. If you are wondering how you can create your own custom models, we'll also come back to that later on. But over here, what this is doing is that it's doing that inference for you on the GCP platform automatically. So over here, as you can see that I already had done that training for myself, and you can see that I get roughly around 71% of precision. Of course, the more amount of data that you upload, the better will be the precision. As with any other machine learning model, the more amount of data that you have, the better will be the prediction for you. So once you have basically trained this model, you can also evaluate it. And then finally, if you want to basically go ahead and use this, you will go to test and use. So I'll quickly navigate to the test and use. Now basically GCP provides you a multitude of different ways in which you can use the machine learning model that you have just trained. So we saw that with the GCP machine as well. So you can either use TF9, TensorFlowJS, CoreML, or even Corel. Corel is for edge TPs. So the one that we are going to be using it for today is going to be the TensorFlowJS. So once you basically go ahead and do it, let's say I'll browse one of the buckets, and let's say I'll just create it over here. Let's say inside this bucket that I've created, and let's say I'll create a new folder. Let's say output new, and I'll just go ahead and create this. And it will go ahead, and once I select this particular folder, it will export our model. And in case you're wondering what is actually the output, so I already have my VS Code open. So if you're able to see this, you'll be able to see this model.listen file. Then you'll be able to see the group 1 shard of 1 of 3 men, group 1 shard 2 of 3 men, and group 1 shard of 3 of 3 men, and then dig.txt. So let's quickly navigate through what exactly all of these actually contain. So primarily, whatever metadata of your machine learning model, that's contained under the model.txt. So basically, this tells you what exactly is your model. So here you can see that this is a graph-based model, and it's again, since it's a neural network-based model, so you can see a lot of the different metadata about the machine learning model itself. Again, we will not go too deep into it. In case you're interested, you can connect with me later on, and we can discuss further this. Then, in case you're not aware, machine learning basically, especially if you're using like neural network and deep learning models, they come with weights, right? So with machine learning, we attach weights to it. So the weights of your machine learning model are consisting of these shards, right? So these represents the weights of the model that has been trained. And this dig.txt just contains the labels of our data. Now I have an accompanying index.html file. Since we are talking about JavaScript, so we are going to be seeing over here, and you can see that how many lines of code you have, like literally less than 20. And out of them, just the few ones that we have used at the top are just installing the necessary packages. So if you were to, let's say, use a React.js application or like this kind of application, you can download the NPM modules. In our case, we are using the TensorFlowJS and the TensorFlowJS AutoML packages that we have used. And then we have a script tag where we are simply just using the image classification function from our AutoML, which will basically take our image that we provide to it, and it will run the prediction on top of that image and will render the results. So let's quickly take a look at the live working example over here. So first what I'll do is that instead of a URL, I'll probably just keep this copied in here. I'll take some of these images. So let's say that this first image is this image of a really good dog, right? So I'll put this image in my, so I'll just say 6.jpg and I'll test it with this. I'll click on go live so that you can navigate to the local environment. So over here you can see that, I'll just zoom it in. So over here you can see that for this dog, we have two different labels, this cat and dog, and the probability associated with both the cat and the dog. So for the cat, it's around 14%, and dog, it's 85%. So 85% confident that this particular image consists of a dog. Then let's say we change it up with, let's say, an image of a cat. So this is any cat. So I'll replace this with an 59.jpg. And let's see, I'll refresh and let's see. So this time you can see that the probability is for the cat and it's 96%. Now let's take an example of an image that exists online. So this is one of the images that's on Wikimedia. Again, this is of a cat. So let's actually test this out on a live, like that is not part of our training or testing data set. Let's go ahead and do this and we refresh. So this time you can see that again, this time we get a cat and it works pretty well. 96% confidence rate prediction for it being a cat. So yeah, this is a very good demonstration for the GCP. But again, what I showed was a very simple example for a single label example. But of course, you can explore the extent of the Google Cloud AutoML, right? And nowadays we have basically come up with even a better version of that, and that's known as Vertex AI. If I'm not mistaken, there was a talk today, likely talk on Vertex AI as well. So Vertex AI is basically a step above the Cloud AutoML. This also basically takes care of MLOps. So if you are interested to not just creating a machine learning model, but you are interested in actually deploying it and also productionizing it, you can use Vertex AI as well with the help of Google Cloud. So what you saw was basically that if you are running a production ready application and you have tons amount of data, then you can use Google Cloud very easily, right? And you can very easily train the model and directly start using it, and you can use it in our web application as well. And I'll not take a lot of time more, just probably another 5 minutes, and I'll quickly just cover the rest of the slides. So this will answer some of the folks' questions in how we basically can write our own custom logic. So with very similar to Python, you can basically write custom machine learning logic from the ground up, from the scratch with the help of JavaScript as well. By the way, here is a very simple example of how what we did was basically running the machine learning model on the browser side. So with TensorFlowJS, you can run both machine learning models on the browser itself. So you don't need a dedicated server, and you can also run it on Node.js as well. So this is an example for what we covered running on Node.js. And finally, coming to how you can basically run TensorFlowJS code on your own. So for that, we basically come with 2 different types of APIs. So very similar to the Python world, we have TensorFlow and we have Keras, right? Similarly, we have an Ops API and we have the Layers API that allow you to write custom machine learning logic in JavaScript directly, and that can interact again either on the browser or on the server side. And what we covered, so we have at the top is the pre-built models, which is in the models that that are pre-built models, and at the end, at the most amount of abstraction, we have the Ops API, which allows you to write custom code, and you can run it both on the browser side and also on the server side. Now, on the browser side, because machine learning inference is very computationally intensive, so JavaScript is a very versatile language, but it's not very performant application, especially if you compare it to programming languages like Rust or C++. So what you can do is there are some backends supported, including WebGL, Wasm, which allows you to basically use your native resources, which are your GPU and your CPU of your computer, to be able to run your inference logics for on the browser to do this inference quickly. And what you can see is that in terms of if you had a question regarding that, hey, how does it perform in terms of performance as compared to Python? So you can see that it performs very closely, and even in certain cases, including the BERT model, which is very popular natural language processing model, it actually performs better, right? And some of the benefits that you get of running it on the browser side is the biggest one is privacy. That you don't need a dedicated server at all to be able to do this inference. Everything happens locally inside of your system. Even if you don't have internet, you can run the model. And the biggest one is privacy, lower cost, because you don't have a dedicated server need, right? You're not waiting for a server to send you back a response once you send in a request. Your request and response, everything is happening locally inside your system on your browser. But of course, if you have much larger, models, you can still use Node.js, which provides you just-in-time compilation, which again is very performant. So you can also run much larger models on the server side as well. But yes, in case you want to get started with TensorFlowJS, these are some of the resources that I would like you to, I will recommend to all of you to take a look at. So you can probably take a screenshot of those resources if you are interested, and if you are a JavaScript developer, and or if you, even if you are a machine learning developer and you want to venture into machine learning in web, you can definitely take a look at these resources. But again, the most exciting part of being in this TensorFlow-based community is that it's not just hardcore data scientists. It's also a lot of fun-loving non-developers who are also using TensorFlow.js to be able to create these superpowers. So probably the one that I really admire is basically this one. The central one at the lowest most column, where you can see this dancing person. This person is based in Japan, who is a professional dancer, and he doesn't know about anything about machine learning or even programming in general. He just knows common like front end JavaScript, and he created this with the help of TensorFlowJS. So you can see that what superpowers TensorFlowJS gives you, and even if you are not a native machine learning developer, tools like GCloud, AutoML, and TensorFlowJS enable you to create such kind of really good applications. So if you're a student, you can use them at hackathons, or even if you are, let's say, a working professional, you can at least start using it to create proof of concept. And now TensorFlowJS is being used in a lot of startups, bigger companies like LinkedIn as well, which use the TensorFlowJS node for performance as well. Well, that's it from my side. I'm open to questions, but yes, if you have any other questions, you can connect with me on Twitter. I'll read hardware, and yeah, I'm open to questions now. Please. Absolutely. So, of course, very rightly said, sir, that of course the core research that is being done, that's still very prevalent. You use either like let's say R or Python or even Julia, right, for scientific computing and research. So that core research is still very prevalent. Although you can still do data science with JavaScript with TensorFlow. There are libraries such as Danforth-based, which are basically having inbuilt support of similar to how NumPy, so you're able to actually work with those. But yes, actually this is primarily centered towards application-driven machine learning, where you basically take some of the existing models, which you can basically convert also from Python to JavaScript, and then use them for application development. Because we're seeing so much more of application-based machine learning today, and because not a lot of people have that capacity to also say deep dive into the mathematics involved or the statistics involved, right? So that's why TensorFlow is really good for application development. Definitely. Definitely.
The cats and dogs example you showed.
I'm really sorry, could you please repeat?
Cats and dogs example you showed.
Yes, yes.
So, in that, the inference is happening in the browser or is it happening in Google Cloud?
No, the inference, see what we did was that if I just open up my Google Cloud again over here, so what we did was that once the machine learning training had been completed, we exported the model and we loaded it into our local application, right? So right now, the inference is actually taking place on our browser. So this inference is not connected to Google Cloud at all. So this is locally on our browser.
If I wanted to run it on Digit Images, how would I? And I want to run it on Google Cloud, is there a way to do it?
Yeah, so basically what Google Cloud allows you to do is, and I'll quickly go back to the test and use, this test and use case. So primarily what it allows you to do is that when you do a new training of the model, it's not showing up over here, but basically you can either choose Google Cloud for doing the inference, or if you want to basically do it on, let's say, lower power device or on the browser, you have all these other options as well. So Google Cloud, if you are using Google Cloud AutoML, it will provide you both options of either running the inference also on Google Cloud or running the inference using these other models that you can see here. So you have both options available to you. But of course, the example that I showcased was 64 images. Of course, if you have billion images, the amount of training time that it will take, it will be hours, 10, 12, 20 hours. So even for just 64 images, it took roughly around 1 hour to train. Okay. Yeah, so for that, we use GCloud definitely. Yes. Yes, absolutely. Definitely. So I will recommend you to think of the ops and the and I'll bring up that slide just a minute. So basically, what the ops layer it allows you to do is write custom logic in JavaScript itself. So basically what about JavaScript, and then you can use either the graph layers or the same model layers, which allow you to basically write that custom logic within the tensors. It will be slightly different in terms of the syntax, but logically it will be the same. So if you're defining, let's say, the dimensions of your tensors, that will be very similar how you define them. So let's say if you have a n cross n dimensions tensor, it will be very similar to define like you define it in Python. You can define it. I have a very quick example if you don't mind, where I've done that. So let me just open up my VS Code. Yes. So basically, the ops API, which is the low level API, is similar to the core TensorFlow, and the layers API is similar to Keras, and obviously Keras.
I think Shivay's talk was awesome. I think even I learned a lot from it, and he'll be hanging around. Definitely follow him. I think he does a lot of content creation, which is great. And you can check out and learn more from him. He'll be around after the talk as well. And a huge round of applause.